Hello everyone. In this video we will see the distance measures between pixels in the digital image processing. So here let us consider capital D as the distance function. We'll consider here an image where we are taking 3 pixels. The first pixel is pixel P with coordinates x comma y. Then we have pixel Z with coordinates u comma v and the pixel Q with coordinates s comma t. Now here for this distance function we have 3 properties. The first property is d of p comma q should be greater than or equal to 0. That is the distance from p to q. The distance from pixel p to pixel q, it must be greater than or equal to 0. Now it will be greater than 0. It should be greater than 0. For equal to 0, the condition is the pixel p must be equal to q. If the pixel p is equal to pixel q, then the distance between the pixels p to q will be equal to 0. So this is the first property. Second property is d of p comma q is equal to d of q comma p. That is, you either measure the distance from p to q or q to p. The distance remains same. That is, both the distance will be equal. Third property is d of p comma z is less than or equal to d of p comma q plus d of q comma z. That is, the distance from p to z, that should be less than or equal to the sum of the distance from p to q or p to q and distance from q to z. Okay, so these are the 3 properties of the distance function. Now here we have 3 distance measures. First is the Euclidean, next is city block, and the third is chessboard. We will have a look on these one by one. The first distance is the Euclidean distance, which will calculate between the 2 pixels p and q, and it is defined by using this formula, that is dE of p comma q is equal to x minus s square plus y minus t square whole raised to 1 by 2, or you can write this within a square bracket. Okay, because we have here raised to 1 by 2, you can also write this as under the square root. Now we'll consider again this figure here. Here we have considered 3 pixels. The value for this pixel, that is the value of the coordinates of this pixel, it is present in the second row and the second column. Therefore we'll write it as p of x comma y is 2 comma 2. That is second row, second column. So it is present in second row and second column. Similarly for pixel q, this is 4th row and 4th column. So it will be 4 comma 4. So q of s comma t is equal to 4 comma 4. Okay. Now what we'll do is we'll substitute these values in this formula in order to get the distance, that is the Euclidean distance. So here x is 2. So x is 2, s is 4 square plus y is 2, t is 4. To simplify this, 2 minus 4, it is minus 2 square is 4, and then again here minus 2 square is 4. So 4 plus 4 is 8. 8 raised to 1 by 2 is nothing but the Euclidean distance between the pixels p and q. This is how you calculate the Euclidean distance. Next is the city block distance. It is also called as the D4 distance. And here the D4 distance between the 2 pixels p and q, it is defined by this equation, that is d4 of p comma q is equal to magnitude of x minus s plus magnitude of y minus t. Again we will take the same values of these pixels here. So p of x comma y will be 2 comma 2 and q of s comma t will be 4 comma 4, that is 4th row, 4th column. Now we'll substitute in this formula. So 2 minus 4, y is 2, t is 4, 2 minus 4. 2 minus 4 is minus 2, its magnitude will be plus 2. Then plus 2 minus 4 will be minus 2, its magnitude will be plus 2. So 2 plus 2 is 4. Therefore, the city block distance between the pixels p and q is 4. Okay, the Euclidean distance was square root of 8, whereas the city block distance is 4. Now here we'll see it by using this image. Now suppose I'll consider this pixel here. The value of this pixel, I'll take it as 0. Okay. Now I want to calculate the value of the second pixel, that is this pixel. Always you have to remember that the value or the value of the pixel between the value of the difference between the pixel values, it will be always equal to 1. Okay, that is it should be between the adjacent pixels. Okay, not these pixels, these two are not adjacent, these two are adjacent. Okay, so the distance between the two adjacent pixels will be always equal to 1. So here I have taken the value of this pixel as 0. Therefore, the value of this pixel which is adjacent to 0, it is 1. That is 0 plus 1 is 1. Similarly, here it will be 1, this will be 1 and this will be 1. This will not be equal to 1 because these two pixels are not adjacent. Now, if I want to calculate the value of this, then what I have to do is, first I have to go from this pixel to this pixel. Then I have to go from this pixel to this pixel. So here 0 plus 1 is 1. The value of this pixel is 1. Then from 1 to, now I'll go from this pixel to this pixel. That is 1 plus 1, 2. So the value of this pixel is 2. Okay. So you can write the value for these pixels. This is 2, this is 2 and this is 2. These one. Sorry. Okay. Next. Now I want to calculate the value of this pixel. Okay. Already I have written here the value of the value is 4, but we'll see how we'll get this value as 4. Again go to this pixel. The value of this pixel is 0. 0 plus 1 is 1. Then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. This is how we get the value of this pixel. You cannot go directly like this. So you have to go adjacently. Okay. Pixel by pixel, adjacent pixels you have to go. This is how you calculate the D4 distance. Next we'll see the D8 distance, which is also called as the chessboard distance. So the D8 distance between two pixels P and Q, it is defined as D8 of P comma Q is equal to maximum of magnitude of x minus s comma magnitude of y minus t. So again we'll consider the same image. So the value of P of x comma y, here it is 2 comma 2 and Q it is 4 comma 4. So again you substitute the values here. X is 2, s is 4. 2 minus 4 is minus 2. Minus 2 magnitude is 2. Similarly here y minus t, that is 2 minus 4. It will be minus 2. Its magnitude will be 2. So the maximum between these two is nothing but 2. Therefore the D8 distance between the pixel P and Q is nothing but 2. Okay, here. Now we will consider one figure here. Now suppose this is an image and we have written all the pixel values here. Now we will see how we have written this. Suppose I'll consider this pixel. The value of this pixel is 0. Okay. Now I want to go from this pixel to this pixel. So it will be 1. From this to this it will be 2. So I have written the values of the adjacent pixels. Now I want to write the value for this pixel. Okay. So this value is 2. So here from this pixel to this pixel, it will be 1. Already this pixel value is 2. Here suppose I have not written any value here. I want to write the value for this pixel. Now 2, the distance between these two pixels, adjacent pixel will be 1. So the value of this pixel will be earlier. It will be written as 1. Now we are not considering any D8 here. Now according to D8, this pixel value must be maximum of these two. Okay. So it means that it will be maximum of 2 comma 1. Maximum of 2 comma 1 will be 2. Therefore the final value for this pixel will be 2. Okay. Similarly here also. Again you consider this pixel as value as 0. So here we are going to the adjacent pixel. It is 1. 0 plus 1 is 1. So the distance between these two will be 1. Now I want to write the value of this pixel. The distance between these two is 1. So Here it will be maximum of 1 comma 1. Now the value of this pixel will be 1. Okay, so this is how you have to complete this checkerboard, or that is a chessboard. So it is called as chessboard distance or the D8 distance. So these are the three types of distance we have seen. Distance measures. One was the Euclidean distance, then D4 distance, that is the city block, and the third is the D8 distance, which is called as the chessboard distance. Hope you have enjoyed and understood the videos. Thank you.